Okay, so today we're going to learn how to use the database called Reaxys to search the Beilstein chemical database. So we're going to begin by going to the University of Delaware library site. That'll bring us to here. And here under databases, type in Reaxys. Okay, and so then if you look under here, that should plug you into this. And if you click here, if you're on campus, it will take you directly to the site. If you're off campus, I suggest you do it on campus if at all possible, but if you're going to try it off campus, I think it should ask you to take you to a proxy site where you can get in by putting in your UDID. Okay, so when you do that, that brings you here, and this looks just fine. So you can click on structures and reactions, as I just did there, and that is fine. And then the next thing you want to do is you want to go into this white box here that says Marvin Sketch in it. Double click on that, and that will take a minute. It's going to load up a plugin called ChemAxon. It may ask you for some permission here in a moment to run this applet. You can say go ahead and run that. Okay, and so that's going to bring you into this structure editor. And so what we're going to do then is I'm going to start by showing you how to do a specific structure search using Reaxys. And so what you're going to do is after you do that, you're going to note how many hits you get and follow the instructions that Jeff is going to give you in terms of your lab. My goal is here to kind of show you how to go through and use Reaxys. Okay, so here we're in ChemAxon, and we're going to draw a structure. I'm just going to randomly draw something so you can go and really, you'll have to familiarize yourself and play with this, but I'm going to go up here and select the benzene ring. I'll draw 2 benzene rings, and then from here over on the left, you can see you have a toolbar, you have a thing that makes a box, an eraser. This icon we'll come back to later. You can select different atoms. I'm going to stick with carbon for now. This allows you to select bonds, single, double, triple, which is really all you'll need to know. And the rest of these things will come to later. So for right now, we just want to draw a single bond, and so we will do that. And there we go. I'm going to draw 2 more single bonds. And then I'm going to draw a double bond here, finishing, let's see, so what else do I want to put in here? Let's go ahead and put in one more atom. So here we are, we're going to look for this molecule called 9-bromophenanthrene. So we're done, we've drawn the structure. Now we've created a structure. We need to transfer this back to Reaxys home base. We do that by clicking on this button called Transfer Query. If I look in background here, you can still see there's the molecule that I drew, but I'm going to keep that in the background for now. I have this set up here. Now this is important. You can say search in reactions or substances. Right now we just want to look for this particular substance. We'll learn how to search reactions a little later. Okay, so I'm ready to go. I'm going to hit search. Okay, and so now this is looking a little small to me because I'm old, so I'm going to hit this zoom in button right here to make the structure a little larger. Okay, so here you go. You can go and you can see there is your structure. I actually found a few additional structures. That's fine. So this H2 means that it's a deuterated analog. Same here, it's a monodeuteurated analog. These are some other things that co-crystallize with a different molecule. So here's the molecule that we're looking for. So this little test tubey thing is actually something that we don't need for this project, but if you ever find yourself in the laboratory doing research, it's useful because it can tell you if your substance is actually commercially available. So it will link you to an outside website called eMolecules. You'll see it flashing up here, 5 grams for $15. It'll take you to a site which will instruct you on how to purchase that molecule. All right, so what else do we show here? So it shows you the types of preparations and reactions involving this compound. If we want to look at just the ways of making it, we could click on this number 15, That will show us all the preparations of it. Or we could go to the 752 some reactions involved with this molecule. So some other information that Reaxys gives us is here under available data. So I'm going to click on physical data. You can see when I do that, it brings up information such as the melting point, the boiling point, refractive index, density, so forth and so on. We should also be able to go on and look, if you see back going up here to the top under spectra, if we click on spectra, that will bring us now a whole list of, and I'm going to actually hide the physical data to make it a little simpler. So under spectra, we can go through and see the different type of spectral spectra that have been collected for this compound. So we see that we have proton NMR, C13 NMR, and these link us to the different papers that cite it. So here we have an Organic Letters 2008 paper. If I want to link to that, I can link on it by just clicking full text. That should open up in a different window, something that I can click on and link. So I'm opening up tabs, and here I'm brought to the website for this paper, which I could click on and then open, and voila, I have the paper that's going to show me how to make 9-bromophenanthrene. I'll have to go into the supporting information in order to find that. Okay, so let's look some more at what we have here under spectra. We have IR spectra, mass spectrometry, some things we haven't really talked about in class yet. So that is it. That is how to do a simple structure search, exact structure search using Reaxys. When we're done here, we want to go back. If we want to do some more work on Reaxys, we can go back to Query. We should be able to double click in this window here, and that will bring us back to our sketch window. So looking at the same structure, you might be asked to say, well, I am really interested not only in 9-bromophenanthrene, so a bromine at this position on this aromatic nucleus, but in any compound that has substitution at this position. So I might be interested in looking for, if I'm looking for, if this is a nitrogen, aminophenanthrene, or I might be interested in 9-hydroxyphenanthrene. I might be interested in finding all the different substitution patterns at that position on a phenanthrene nucleus. So how would we do that? The way to do that is to delete that group altogether and to tell the computer that at this specific site that you want to be inclusive in your search. So basically anything there that's not a hydrogen, including a hydrogen atom that has this core structure, otherwise unchanged, we want to look for. So how do you do that? We have to go in and tell the computer to put what we refer to in Reaxys language as a free site. To put a free site in, we go here and you can see I just clicked on this periodic table looking thingy here. So that pulls up a periodic table. Now the periodic table and advanced features. The periodic table, of course, is useful because if you want to put in an atom that wasn't in this short list, you would have to go into the periodic table, say I want 10. What you do, you click on 10 and then hit close, and then you could select a bond and it would put a 10 in. So that's one thing that icon can do. It can bring us to the periodic table. What we want to do is put in a free site. So this is a little counterintuitive, so pay attention. What we end up doing is we go under and click advanced, and the way that we tell it to search for the maximum number of sites is to click this S- substitution count. Okay. The easiest way to do it is instead of, you can hit plus all the way up to 6. If you hit minus, it brings you backwards to I'll show you what happens. So if you go here now, so I close that window, and now I'm going to click there, and it's going to say S6. If I kept clicking, it decreases all the way back until I get to the beginning. So instead of hitting S plus and going up to 6, I hit S minus. That gives us just a maximum number of free sites at that position. All right, so now what I'm going to do is to transfer this query. We've set our free site here by increasing the substitution count to 6, and now I'm going to search. And now we get a much larger hit set, 4,742 hits. We can see our parent phenanthrene. We have 9-bromophenanthrene. We have an aldehyde. We have a hydroxyl group. We have a methyl group. We have an amino group. So we can now, one by one, go through each of these molecules and look at them individually. Okay, so if we want to look at phenanthrene itself, we have preparations. We have reactions. Let's just pull up some reactions here. That will take a moment. Now notice here at the top, we have our subcategory of phenanthrene. Then we've gone a sub of that into the reaction. So that's where we are now. If we want to get back to where we were before, all we would have to do is go and click click back here to get to all the substances we just looked at. Okay, so what we had done before, we looked at the reactions of phenanthrene. We can see that they're here. So here are reactions that make phenanthrene. So here we're taking this dibromo compound and doing something to it and closing the ring. Here we're taking phenanthrene, we're actually oxidizing it, take a dialdehyde. So you can go through and look at these if you like. This is one of the things that comes out. So you can go back to your parent. You can do this for any compound. So now you can look, say at your aldehyde compound. You can look to see if it's commercially available by clicking on the beaker thingy there, and you can go to e-molecules. You can see that it is. You can go and look at the physical data if you want to find out the melting point. You can see the melting point is 99 to 100 degrees. Different people, you'll notice, get slightly different melting points. You can find the boiling point, some other things about it. You can go through here and instead of looking at the physical data, you can look at the spectral data. Okay, so we've already done this for 9-bromophenanthrene. You can just go down the list and look at all these molecules. So that is how you do a substructure search using free sites. Let's do just one more of these. If we go back to our query, we'll click again. So going to take just a regular carbon atom. I'm going to go over that. That's going to remove the free site here. Let's go again and pick our free site button again. Again, the easiest way to do that is go under advanced. Just hit this S minus, this substitution count. And so when I click here, that's going to put free site there and a free site there. So now I've got free sites at these positions on the phenanthrene, but we should have hydrogens at these positions up here on the bridgehead. So if we transfer that query, now we're looking at this. We do a search. Okay, so notice, just because you told it it could be something other than hydrogen, it will find molecules with hydrogens at those positions. So this has a hydrogen at this position and a hydrogen at that position. Here it found the one with a single methyl group here. But if you go down, you'll see that you do find disubstituted. So you'll find monosubstituted or disubstituted phenanthrene derivatives this way. If you want to look at something on the next page, you can page over by going down here. I usually go and increase the number of results to maximum of 99 because it's easiest to just keep scrolling down as you go. All right, so the last thing we will do is we will go back and show you how to do a reaction search using Reaxys. So let's look and see if we can, let's double click here again. So I'm going to go through and in this case, we want to see if we can look for a particular starting material going to a product. So I'm going to lasso this whole thing. Oh my goodness. I'm going to try to move it if I can. There it goes. Okay, so clicking in the middle. I'm going to lasso it, and I'm going to hit Command C. I'm going to see if I can edit, copy that. Sometimes it lets me do this, sometimes it doesn't. Here, let me paste it. All right, and so I've drawn the same structure twice, and what I want to look for is if I can look for reactions where I start with phenanthrene and produce a particular product. Say I'm going to look for this product. I'm starting with phenanthrene, I'm making 9,10-dibromophenanthrene. So to make this a reaction search, what I'm going to do is I'm going to put an arrow here, and I'm going to, basically that's going to let Reaxys know that this is my starting material and this is my product. At the end, I'm not going to forget to transfer the query, and that's going to do that. Now this is going to show up in reactions. Notice that substances here is now no longer an option for us to click. So if we search that, that will show a much simpler product of our search, just 2 entries, and it's going to show us conditions here, so using bromine and sodium bromide and acetic acid, and the second paper using phosphoric acid, trimethyl ester, and bromine. This is from a 1966 paper, this is from a 1967 paper, I'm sorry, 76 paper. Again, we can just click on this and we can get the paper. So if I click on full text, that should open up a link. Then I'm going to click on this again. And if I'm patient, it pulls me up to the paper describing rates of bromination of polynuclear aromatic hydrocarbons. Okay, so that works. So one last thing I'll show you is, let's go back then. So this was a successful search. Really what we wanted out of this was our references so that we could get conditions. If we go back to the query, I'll show you one thing, just that we can also, in reaction searching, we can also use our free site feature. So if we want to say, look for, you know, preparations of turning, let's say 9-bromophenanthrene into anything other than a bromine atom, what we can do is we'll go and select our free site. Again, we clicked on the periodic icon. We'll go to advanced and then hit X-, close that, and then we're just going to click here. Okay, so see what we're saying? We're saying that our starting material has a bromine at this carbon, whereas at this carbon in our product, it could be attached to anything, not just the bromine. And so we'll do this search, and that's going to pull out 473 hits. Okay, and so here we're taking, I'm going to zoom this in because of the, okay, so that looks a little better. So you can see here we're taking a bromine and methyl acrylate, and we're coupling that piece onto here. Here we're taking a boronic acid, and we are making a carbon-carbon bond. Okay, so you can go through and look at these, but this is another useful feature of Reaxys, that we can incorporate free sites into our reaction searching. Okay, so that's our brief tutorial on using Reaxys. Good luck in completing your out-of-class assignment this week for lab. Thank you.